viewers, once again welcome to my channel. So we are continuing with our concept of the latent heat of fusion and the latent heat of vaporization. So in this example here, we shall be required to determine the specific latent heat of vaporization, and according to this question here, it falls under the category of finding the specific latent heat of vaporization of a liquid, in this case which is water, and basically by the method of mixtures. So to start with, we have a calorimeter of mass 35 grams and specific heat capacity of 840 joules per kilogram per Kelvin, contains 143 grams of water at 7 degrees Celsius, and dry steam at 100 degrees Celsius is passed through the water in the calorimeter until the temperature of water rises to 29 degrees Celsius. So if the mass of the steam that condenses is 5.6 grams, so we are required to calculate the heat gained by the calorimeter. Well, the heat that is gained by the calorimeter, to start with, remember the calorimeter and the water at first they were at 70 degrees Celsius. So the moment we pass in steam that is at 100 degrees Celsius, we expect the water and the calorimeter to gain some heat energy due to the temperature increases. Okay, so if you are to calculate the heat gained by the water together with the calorimeter, so wherever we have a temperature change, so we make use of this heat energy, where we have remember the heat energy will depend on the mass, the specific heat capacity, and the temperature change. So in this formula here, I have the mass of water, the specific heat capacity of water, times the temperature change. That is for water. Then also heat that has been gained by the calorimeter is basically the mass of the calorimeter, specific heat capacity of the calorimeter times the temperature change. Please note that the water and the calorimeter will have the same temperature change, reason being initially they were at the same temperature. And finally we shall have the same final temperature after the mixture has been stirred and then under thermal equilibrium or under steady state. So we shall have the same temperature difference. So now to substitute, we have the mass of water here to 35 grams. So the moment you're substituting in a formula, you're required to substitute every unit in its standard units. So we shall be required to convert this mass, which is in grams, to kilograms. This mass of water to kilograms. So if you have to convert to kilograms, you basically divide by 1000, then multiply by the specific heat capacity of water, which is 4200 joules per kilogram per Kelvin. Okay, then multiply by the temperature difference. So the final temperature of the mixture was 29 degrees Celsius and the initial was 7 degrees. So you have that temperature difference. Then plus the mass of the calorimeter, which is 35 grams. So we are also required to change the 35 grams to kilograms by dividing by 1000. Then multiply by the specific heat capacity of the calorimeter, which is 840, multiplied by the same temperature difference as that of the water. Okay, so the heat that has been gained by the calorimeter and the water, when we try to compute this here, it leaves us with 13,213.2 joules plus 646.8 joules. So that is coming from heat that has been gained by the calorimeter. Then when we try to sum up these two, it leaves us with 13,860 joules as the heat that has been gained by the calorimeter and the water. Now, for part 2, Part 2, we are required to find the specific latent heat of vaporization of water. So at this point here, you can feel free to pause the video, go through this example here, and then see whether you come up with what we shall come up with. Okay, then for part 2, we are required to find the specific latent heat of vaporization. Okay, so in this, the expression that we are to use here, we shall look at our steam. Remember, steam has been passed through the water in the colorimeter, which was initially at 7 degrees Celsius, and steam is coming in with higher temperatures of 100 degrees Celsius. So we expect the steam to lose the heat definitely to the colorimeter and the water. But however, as the steam is losing its heat from 100 degrees Celsius, there will be a change of state from steam to liquid, and then in a process that is called, well, condensation. Yeah. So this steam here will change state, and then that heat that is required for it to change state is basically the latent heat. So it will be given by the mass of the steam times the specific latent heat of vaporization. Now, after the steam has been converted to liquid or has cooled down. So, but remember that occurs at a constant temperature, which is 100 degrees Celsius. Now, after it has converted its state from vapor to liquid, now we shall have a temperature difference. So it will drop from 100 degrees Celsius to the final temperature of the mixture that you can talk about. The final temperature of the mixture, which was 29. And now this will equal to the heat that was gained by water and the colorimeter, which we calculated for in the first part here. So there we shall just have to substitute, no computing again. Now, we add the mass of the steam which was condensed, and that was 5.6 grams, and therefore here where I have the mass of steam, it's 5.6 grams, you convert it to kilograms by dividing by 1000 here, multiplied by the specific latent heat of vaporization that we are looking for. Then as the steam after steam converting its state from vapor to liquid here, so it has to condense. Well, now the mass of steam that condensed is 5.6 divided by 1000, and in doing that we are converting it to kilograms. Now remember, this steam has changed the state to liquid form, and specifically water. So that's why we go ahead and now use the specific heat capacity of water, then multiplied by the temperature difference. Remember, steam came with 100 degrees Celsius and the final temperature of the mixture was 29. So it is 100 minus the 29. So doing the computations here, in this first expression, it leaves us with 0.0056 LV is equal to 13,860. Remember, we have a plus here, so it will have to cross equal signs, or when we subtract the value that we get here on either side. So this other side, on the right hand side, we shall have the 13,860 joules minus 1,669.92 joules. So this leaves us with 12,190.8 joules, and on the left hand side we have 0.056 LV. So shall make LV the subject by dividing through by 0.0056, which is this at this particular point here. And then simplifying this leaves us with 2,176,800 joules per kilogram as the value of the specific latent heat of vaporization. Thank you so much for your attention.